Hi there, and welcome to this month's STEMbox lesson. I'm Kina, the founder of STEMbox, and today we're going to talk about chemical batteries. Before we can talk about batteries, we need to know a little bit about atoms. There are three main parts. There are protons that are positively charged, electrons that are negatively charged, and neutrons that carry no charge. Electricity is made of electrons, and it's the flow of electrons specifically. All that you need to remember for today are that electrons are negatively charged, and they are what makes an electrical current happen. By the flow of electrons, that is how we power all of our phones, how we power our lights. Electrons are responsible for electricity. Now that you know about atoms and electrons, we can talk about the three main parts of batteries. You need an anode, something that's negatively charged, meaning it has a lot of electrons, and a cathode, something that's positively charged, meaning it has less electrons, so it wants more. And to make that happen, you need an electrolyte, which for us is going to be our lemon. A quick note about lemons. As I'm sure you've noticed by the stinging in your cuts or the sour face you have to make when you drink lemonade, lemons are extremely acidic. Inside of every lemon is something we call a citric acid. For our purposes, it's important to know that atoms are acidic because they're a powerful oxidizer that can strip electrons away from our zinc nail, and they can also create reduction reactions, meaning they will introduce electrons to hydrogen atoms and therefore make an H2 gas. In our experiment, the anode is the galvanized nail. It's covered in zinc, meaning it has a ton of electrons to spare. The cathode is the copper. The copper doesn't have as many electrons, and so it wants to gain more. But we can't just stick them together and get a current going. We have to give them something to travel through. So when they're in the electrolyte, we're going to connect a nail to a wire, and the electrons are going to flow through this wire into this copper. But while they're moving across, we might as well make them do some work, which is why you can add something like a light bulb in between a current to make it power on. So the electrons that move through the wire will also have to move through this bulb, which will power it on. In this battery, the zinc has only so many electrons to give before we need to start stripping electrons from the zinc atom. This is where the lemon, the citric acid inside the lemon specifically, is great. Oxidation will strip the electrons from the zinc atoms and send them across the wire to the copper to power your bulb. But then the zinc ions go into solution, and then we don't have to worry. Eventually, this nail will corrode because we're tearing apart the atoms from the electrons and we're moving ions into solution, and that's why you can get a rusty nail or something more brittle later on down the road. That's why batteries eventually run out of juice. So now that we know all about batteries, we know about anodes, we know about cathodes, electrolytes, everything basically, we can run through the entire circuit of a lemon. So step one, our lemon is going to oxidize our zinc nail. It's going to strip away the electrons from the zinc atoms, and the electrons are going to flow into the wire, do some work along the way by powering our LED bulb on, flow back into the wire. Then they're going to go into this copper wire, but we don't want a buildup of electrons here. And thankfully, our electrolyte does a great job of making a reduction reaction, where the electrons pair up with a hydrogen atom in solution because lemons are acidic. And that is how our lemon battery works. Now that you know how lemon batteries work, we want to see what you can come up with at home to make an even better battery. You can try different fruits. You can try adding more lemons, less lemons. It's totally up to you. Share your results with us by tagging us at #STEMbox. We're on Facebook, Twitter, and Instagram. We'd love to see what you come up with. I'd also love to give a huge shout out to our sponsor this month, Greenworks Natural Cleaners. They are a fantastic support system for girls in STEM, and they were even founded by a female chemist, Maria Ochimogo. To learn about Maria and what they're doing to support girls in STEM, check out this cool video they made. Anyways, thanks so much for watching. It's been a blast teaching you about lemon batteries, and I can't wait to see you guys next month when we talk about aviation and aerodynamics. Have a great day, and we'll see you later. This has been Kina with STEMbox.